Okay, introduction. This project introduced MATLAB simulating by design and analyzing an electric circuit. The primary goal is to determine nodal voltage while varying components like resistor, voltage source and current source to study their impact. A user-friendly GUI is developed in MATLAB to streamline nodal analysis and compare results with simulation. The hands-off approach reinforces theoretical concept and building practical skills in circuit modeling, simulation and GUI design. Finds are compiled in a detailed report and shared via a video presentation for comprehensive understanding.
Assalamualaikum dan selamat sejahtera. Nama saya Bazli bin Abdul Rahman. Nombor metrik AE230005 dan floor saya dari group 3 dan saya akan terangkan untuk bahagian simulation untuk simulation. So this is the my circuit. So kita ada power source dia, power source 2 sini. Lepas kita ada current control voltage source dan kita ada 3 voltage sensor untuk cek V1, V2 dan V3 kita. Kita ada current DC current source dan kita ada 5 resistor here. So untuk complete circuit ni, kita first kena ada kita punya solver configuration untuk run the display, dan juga kita kena ada kita punya electric reference sebagai kita punya ground dia lah. So kita perlu letakkan display dia, dan juga kita kena ada kita punya PS simulating converter. Ini untuk dapatkan dia punya display lah, nilai dia. So this is the circuit. So bila kita run, kita boleh dapat dia punya nilai. So bila run, Assalamualaikum dan selamat sejahtera. Nama saya Bazli bin Abdul Rahman. Nombor metrik AE230005 dan floor saya dari group 3 dan saya akan terangkan untuk bahagian simulation untuk simulation. So this is the my circuit. So kita ada power source dia, power source 2 sini. Lepas kita ada current control voltage source dan kita ada 3 voltage sensor untuk cek V1, V2 dan V3 kita. Kita ada current DC current source dan kita ada 5 resistor here. So untuk complete circuit ni, kita first kena ada kita punya solver configuration untuk run the display, dan juga kita kena ada kita punya electric reference sebagai kita punya ground dia lah. So kita perlu letakkan display dia, dan juga kita kena ada kita punya PS simulating converter. Ini untuk dapatkan dia punya display lah, nilai dia. So this is the circuit. So bila kita run, kita boleh dapat dia punya nilai. So bila run, dan kita dapat dia punya nilai lah. Itu saja daripada saya. Sekian, terima kasih. Jadi ni nilai yang kita dapat daripada bila kita run kita punya simulation. Sekian daripada saya, terima kasih.
Like Magenta, my metric number is CE240234. So I'm gonna show you the simulation for the GUI, the graphical user interface. So this is my GUI graph, and here I have used there are multiple options like push button, slider, radio button, checkbox, edit text, and static text. So the upper here, the enter the voltage value. This text is put in the static text, and those and those. These six are the static text, and these boxes are the edit text. And this the calculate one is a push button. So I'm going to be show you the coding first. So here's the coding for the GUI. When you key in the diagram for the GUI, it will automatically pop up. And here are the coding I've put key in. So here I have tagged the first. This first box is tagged as input voltage or the input V. So here is the coding for that, the first box. And the second box is the current one. I've keyed in as the A, which is considered ampere, and input I tagged it as input I. And for the third box, it is the resistor R, and the tag is the input R. And for the this is the formula for the equation. I have keyed in the formula as Z, and here is the formula for the second part, in the matrix form. And here's the main formula: V equals to Z per B. So I have keyed as to for the MATLAB to easily identify, because it's mostly uses the matrix as main form. So here to find the node 1 V1 is V1 and V2 V3. And for the V1, this box I have tagged it as output voltage 1 or the output V1. And for the second box, I have tagged it as output V2, and the third box as output V3. So here's the total coding. I have keyed in this coding under the function for the push button or the calculate button at the callback. And these are all the other codings for the other edit text. And so I'm gonna run it now. So here's the outcome. So when we key in output voltage here, the voltage value, the current value, or the resistor value, and then you need to press the calculate button or the push button to get these answers. So I'm gonna now compare the results with the calculation from our coding. So here, this first graph is a constant ampere and then constant voltage, but the resistor is constantly increasing. So we are gonna compare it and see the results in both. So here I've used the resistor 2 ohm, 1 ampere, and 20 volt, and the answers are for the V1 it's 0.9319 voltage, for the V2 is 0.53763, and for the V3 is 1.1828. So you can see that it is the same. So I'm going to be trying another resistor value. For an example, I will try the 4 and then calculate. So you can see that the results match here: 0.8902, 59047, 1.3056. So this is for the registers value. For the second, I will try changing the current values. So here I will change the current value. Oh, first I show you this. With the current value of 1, we get the same values: 0.9319 for V1, 0.53763 for the V2, 1.1828 for the V3. So I'm gonna try another one. So let's try the 5. So here you can see that negative 93907 for the V1, negative 8.4946 for the V2, and then negative 2.6882 for the V3. So for the next table, we have the constant of resistor value, current value, but the voltage value is changing. So I'm gonna try this one. Voltage, we calculate, we can see that 0.9319, 537763, 1.8284 V3. So I'm gonna try another one, for example 8 voltage. Here we get the same results, negative 2.92939 voltage. V2 is negative 1.7849 voltage, and then V3 is not 3 because negative 1.5269. So we can see that mostly the results we get from the calculation and the GUI simulation are same. So this is the GUI simulation, and for this coding I've labeled it to make it so that node 1 equals to, it pops up as node 1 equals to the answer the calculation, and then behind it got a V, so that it pops up as like this, node 1 V1, because you can see that I've keyed that this has the same, so that it can pop up like this to make it easier to understand. And this enter the voltage value of these tags to make it easier for the users to key in the value and see where to key in the value. And then the V1, V2, V3, which is static text for you to easily see this. So that's all for the simulation, and thank you very much.
Assalamualaikum. My name is Ahmad Mukris bin Razan. My metric number is DE230116. Today, I would like to present about the calculation. First of all, we use a nodal analysis for solve the problem. So, for the calculation of node V1 is 20R multiple with V minus V1 over 20 equal to V1 minus V2 over 5 plus A plus V1 minus V3 over R. Next, the first equation is 5R plus 20 multiple with V1 plus minus 4R times V2 plus negative 20 times V3 equal to RV minus 20AR. Next, for the node 2 is V1 minus V2 over 5 equal to V2 minus V3 over 5 minus 4 times V1 minus V3 over R, and all this equation multiplied with 5R. So the second equation is R plus 4 V1 multiple with V1 plus negative 3R multiple with V2 plus R minus 4 multiple with V3 equal to 0. Next, for the node 3 is V1 minus V3 over R plus A plus V2 minus V3 over 5 equal to V3 plus 10 over 15 multiple with 15R. And the equation for the 3 is 15 multiple with V1 plus 3R multiple with V2 plus negative 4R negative 15 times V3 equal to 10R minus 15AR. So that's all for me. Thank you.
For calculation of this lab report, this project showcase the practical use of MATLAB Simulink for electrical circuit analysis. By varying circuit components and studying their impact on nodal voltage, we gain insight into circuit behavior under different conditions. Developing a MATLAB GUI provide an intuitive way to perform nodal analysis and validate result with Simulink. The outcome emphasizes the accuracy and versatility of these tools, bridging theoretical knowledge with practical application, enhancing both technical and conceptual understanding.